Okay, good morning students. So in this video lecture, explain about the list data structure. You know what is the array data structure? And in this class, I explain what is the difference between array and list data structure. Okay, you know what is array and what is the declaration of array? How to read the data into the array. And elements of the array are stored in contiguous memory locations. Elements of the array are stored in contiguous memory locations. Okay, what is the meaning of contiguous memory locations? Okay, that means you can see the meaning of contiguous through the example program. Look at here. Here, x is the array variable of the char type. What is the size of the array? It is 3. Okay, and here I am displaying the addresses of the positions of the array. Here how many positions are created for this array variable x? 3 positions. X of 0, x of 1, x of 2. That's all. Okay. X of 0, x of 1, x of 2. Okay. And here I am assigning the data to the array variable x. 3 characters. Now the data is assigned. Okay. X of 0 holds the character A, x of 1 holds the character B, x of 2 holds the character C. Okay. Now we can, you know how to display the values from. So you can display the array elements using the for loop. If it is the one dimensional array, one for loop is used. If it is the two dimensional array, nested for loop is used. Okay, here it is one dimensional array, so you can display that you either using the for loop or you can display the individual elements one by one like this. Okay, printf. It is the char type, so the format code is %c. So the position of the element is x of 0, x of 0. Okay, and also you can display printf. Here it is x of 1. Like that you can display x of 2 also. Okay, and here the next statement it is here the format code is %u, and here I am displaying the address of x of 0, address of x of 1. Okay, and you know that int x, int x, what is the meaning of this? So a variable is declared, it is of integer type, and the name of the location is x, name of the location is x, and that location is capable of holding only the integer elements. The size of the location is 2 bytes. Size of the location is 2 bytes. Okay, like this. A location will be created in the memory of the computer. Like this, a location will be created in the memory of the computer. Here, this location is of the integer type, so it holds any integer constant, for example 5. And the name of this location is, name of this location is, it is x. Name of this location is x. And this location is also having the address. What is the address of this location? Okay, how you can access the element 5? You can access the element 5 either through the name of the location or through the address of the location also. Okay, that is, for example, how I can call the students either by the names of the students or by the registered number, roll numbers of the student. Okay, so every person in the universe is having a unique identification. Okay, like Aadhaar number, PAN number, like that. Okay, and here also the every location in the memory of the computer is having the address, that is the memory address of the location that will be created by the system. Okay, so what is the address of this location? Here you can access the element 5 either by using the address of the location or by using the name of the location. Okay, that you can here. And here %u is the format code to display the address of the location. Okay, now here it is the output. So use the \n. So here the x of 0th location, the character is A, it is displayed. And x of 1th location, the character is B, it is displayed. And next you are displaying the addresses of the uh, array positions. Okay, address of x of 0th location, address of x of 1th location. It is okay. So the last digit here it is 5. Okay, and here it is 6. So what is the difference between these two? Here the difference is only 1. Okay, here it is the char data type. The size of the char data type is 1. So uh, first element, address of the first element is so and so, the last digit is 5, and the next element should be the next value 6. Okay, for example, if you write here float data type. Okay, now write the floating point constants here. Okay, now it is the floating point array. Okay, now you can display the and change the format code also here. Percent f. Okay, okay, now it is x of 0th value 10.00, x of 1th value it is 12.00. Now the address is here, the last digit is 2 and here the last digit is 6. Then what is the difference between the address of the x of 0th location and address of x of 1th location? It is 4. Why here it is the difference 4? Why in the previous case, that is in case of char type, it is 1. Okay, here the size of char data type is 1 byte, so the difference should be 1. Here the size of float data type is 4, so the difference should be 4 bytes. Okay, if you use the integer type, size of int data type is 2 bytes, so the difference should be 2 bytes. Okay, so ఖచ్చితంగా 2 bytes difference తోనే వస్తుంది. Okay, like that all the array elements are stored in the contiguous memory location side by side. Okay, and if you take another example, int a comma b. Now a b are two different variables, those are normal variables. Float to data type. Why? Because if you use the float here, again no need to change the format code, that's why I have written float data type. You can check for the integer data type also. Okay, now check this. Right, ampersand, no, ampersand. So actually, if you check this program in the offline C software, offline compiler, definitely you will get the two addresses. Those are different addresses, not side by side like this. Okay. So this is online compiler. So system is taking the addresses for this example program also side by side. That is contiguous. So first address is 36 and then the difference 4, it is next address is 40. Okay, but in offline compiler it is not uh, like this. Okay, it displays the separate addresses, not like this side by side. Okay, for example, first address may be 36, second address may be some not 40, some other value. Okay, so 40 means it is side by side, పక్క పక్కనే ఉన్నాయి. ఓకే, సో 40 అయితే ఖచ్చితంగా డిస్ప్లే చేయదు, వేరే సమ్ అదర్ అడ్రస్ డిస్ప్లే చేస్తుంది. It is in the online compiler it is displaying like this, but in the offline compiler definitely you will get the different address, not 40. Okay, ఓకే, మనం ఎన్నిసార్లు రన్ చేసినా సరే డిఫరెన్స్ 4 తోనే వస్తుంది, బట్ ఇన్ ఆఫ్లైన్ కంపైలర్ డిఫరెన్స్ 4 అయితే ఖచ్చితంగా ఉండదు. అవన్నీ కూడా ర్యాండమ్ లొకేషన్స్లో ఉంటాయి. The variable location of variable A is at some and location of variable B is at some place. Both are at the different places. Okay, not like this if you use the offline compiler. Okay, okay, that is the meaning of contiguous memory locations. Okay, so now if you use the variable int x comma y, now the address of x and address of y differently, not side by side. Okay, x the location of x may be 1000, the location of y may be 2000. But if you use the array like this, all the array elements are stored in contiguous memory locations. So first location you have 0, suppose it is 1000. Second location definitely it is 1002. The next it is 1004. Next it is 1006, 1008. But here int x comma y, this is not array variable. So the location of x, address of x and y, those are not side by side. Okay, those are not contiguous. Okay, maybe different, maybe side by side. Okay, so we cannot give 100% surety for the uh, that x and y locations of addresses of x and y, those are side by side. Okay, we cannot give the surety, but here it is 100%, those are stored in contiguous memory locations. Okay, but here in some compilers maybe in contiguous memory locations, but in some compilers definitely those are not stored in the contiguous memory locations. Okay, this is about the array data structure. What is the data representation of the array? Data representation of the array is array index starts from 0, ends with 1 less than the size of the array, and all the elements in the array are stored in the contiguous memory locations. Okay. Now you can access any element of the array. I can display the a of I can display the here here the variable is int a of 5. The variable is int a of 5. Okay, so how many locations? A of 0 to a of 4. Okay, so I can display the any individual element from the array. I can display the first element, that is a of 0, printf percent a of 0. I can display the a of 1. I can display the a of only the element a of 4. I can display only the element a of 3, or I can display all the elements using the for loop. Okay, I can display the individual elements, or I can display the all the elements from the array. Okay, here you can access any element. That is, array data structure allows the random access. array data structure allows the random access. Okay, you can display any element from this array. There are no conditions. Okay, there are no conditions. So this is the array. Here I can display only the element AF4, only the element AF1. Or you can display the address of 3 also. You can display the address of any element from the array and value of any element from the array. Okay. So here. So here fourth element it is 10. Here one element it is 6. It is displayed and address of here fourth is 16. Address of here the previous one it is 12. Okay. So third F3 is at the 12th address of that is 12 last two digits, and your fourth location address is 4 bytes, next to 4 bytes space. Okay, 16. Okay, why the difference is 4? The size of the float is 4 bytes. Okay, so like that a of tooth location is 8 136474920 8. A of tooth location is 4. A of one location is 0. Okay, you can display that. A of one location is 0. Last digit is 0. Okay, every time the elements ప్రతిసారి మనం రన్ చేసిన ప్రతిసారి అదే అడ్రస్లో స్టోర్ అవ్వాలని రూల్ ఏం లేదు, చేంజ్ అవుతూ ఉంటాయి. ఓకే, so first address and last address you are displaying. So now this time the address is first address is now it is random locations you are getting. So first address is 76. Okay. So to avoid confusion, write A of 0 first and then A of 4. Okay. Okay. First location is at the last two digit. Look at the last two digit. First address is at 44. That means A of 0. A of 0 is at 44. So what is the address of A of 1? 48. What is the address of A of 2? Address of A of 2 is 52. And then A of 3, 56. And then A of 4, it is 60. Okay, yes, it is 60. Okay, like that. Okay, you can check this for any example. And here also it is first it is 40 and last it is 56. Okay, total how many elements? 5 elements. So 5 fours 20 bytes. Okay, so first 40, 44, 48, 52, 56. Okay, now it is also, now also it is correct. Okay, like that all the array elements are stored in contiguous memory locations. Okay, that is about the array data structure. Now come to the list data structure. So list data structure is a little bit different from the array data structure. In the list data structure, the elements are stored not in the uh, contiguous memory locations, the elements are stored in non-contiguous memory locations. Non-contiguous memory locations means those are not side by side. Okay. Suppose if you declare the variable, if you declare the variable using the linked list, so this is the declaration of variable using the array. Here array data structure is used. Okay, either array or list. The definition of array and list both are same, group of elements. Array is the group of element, list is also group of elements. Okay, list is also group of elements. Array is the group of elements. But array data structure, what is the representation of data in the array data structure? Contiguous memory locations. But the representation of data in the linked list data structure is non-contiguous memory locations. Okay, if you use the array data structure to store the elements, then what is the representation of the data in the array data structure? Those are stored in contiguous memory locations, starting from a of 0 to a of n, a of n minus 1. But if you use the linked list data structure to store the data, the elements are stored in non-contiguous memory locations. Non-contiguous memory locations. Okay. And look here, if you use the array data structure, if you use the array data structure, now using this contiguous memory locations, you can easily calculate the addresses of all the other remaining elements if you know the address of any element in the array. Okay, suppose I know the address of the element 9. I know the address of the element 9. Then I can easily calculate the address of 10, address of 8, address of 6, address of 5. Why? Because all these elements are stored in contiguous memory locations. So with the difference 4, I can easily calculate the addresses of all other remaining elements. Okay. Why the difference 4? The data type is float. So size of float is 4 bytes. So with the difference 4, I can easily calculate the addresses of all the other remaining elements. Okay. అయితే ఏదైనా ఒక్క ఎలిమెంట్ అడ్రస్ మనకు తెలియాలి. ఓకే, ఏదైనా ఒక ఎలిమెంట్ అడ్రస్ ఎక్కడ స్టోర్ అయిందో మనకు తెలిస్తే ఖచ్చితంగా రిమైనింగ్ ఎలిమెంట్స్ కూడా ఆటోమేటిక్గా అక్కడే స్టోర్ అవుతాయి. ఓకే, but we cannot calculate the addresses in the list. We don't know where the element is stored. Okay, why? Because those are not stored in non-contiguous memory locations. Okay, so what is the data representation of the linked list? So look here and here, see the one more difference. So here it is the array. So it is a of 0. So it is a of 0, a of 1, a of 2, a of 3, a of 4, a of 5, a of 6. Okay. Suppose here the element is 5, element is 9, 10, 4, 3, 100, 50. Okay, so that is the data. Suppose take the data in the sorted order. Now the data is in the sorted order. Okay, assume the data like this. Okay, sorted data. Now suppose the address of the 0th element is, suppose it is last two digit 10. Okay, last two digits 10. Okay, now the now you can easily calculate the address of next. It is 12. Why? Because 12, the array type, suppose the array is the integer type. Okay, so int data type size is 2 bytes. So the next address location is 12, and the next is 14. And the next is 16. It is 18, 20, 22. Okay, like that you can easily calculate the addresses of the remaining elements if you know the address of any element from the array. Okay, but in the list data structure, and also here observe one more point. This is the cell, memory cell. This is the memory cells. Okay, and to this memory cell, these are the name of the location, and these are the addresses of the location. Okay, so the memory cell, what it contains? It contains only the data. It contains only the data. Okay, no need to hold the address here. No need to hold the address. Okay, why? Because all are stored in side by side contiguous memory location. So no need to remember the address of the next element. No need to remember the address of the next element. Why? Because it is immediately the next address. Okay, so no need to remember. Okay, but in the list, elements are stored in the contiguous memory locations. Like this. Okay, ఇక్కడ ఫిగర్ డ్రా చేయడం కష్టంగా ఉంది. So look at here. So this is the list representation. Here this location is one element. That means this is one memory location. This is another memory location. Third memory location. Fourth memory location. So, okay. First element is stored in the first location, second element is stored in the second location, third location, fourth location. Okay, here the memory location is divided into the two parts. ప్రతి దాంట్లో ఒక 2 parts ఉన్నాయి కదా, మెమరీ లొకేషన్ is divided into the 2 parts. Okay, first part contains the data element, data. Second part contains the address of the next element. Second part contains the address of the next element. Whereas in case of arrays here, no need to hold the address. Why? Because the next element is at the immediate address. Okay, so no need to hold the address here. But in case of list, elements are not stored in contiguous memory location. So we need to hold the address of the next element where it is stored. Okay. So that is every location, every memory location is divided into the two parts. One is the data part, another one is the address part. But in case of array, but in case of array, so here there is no address part. There is no address part, only the data part. No need to hold the addresses. Why? Because these are the contiguous memory location. So no need to hold the address. Okay, it is the immediate. Okay, but in case of list, we need to hold the address of the next element also. Okay, first part is the data part, second part is the address part. This address part holds the address of the next element. That means this A. So here the data element is A. The next is the address part. So this address part here it holds the address of the B. Here in this location, this holds the address of C. Here in this location, this holds the address of D. Here in this location, there is no next element. Okay. So here it is null. Null indicates there is no next element. It is the last element. Okay. And the first node is the head node. First node is called as the head node. Okay. And the address of the last element, address part of the last element is null. Last location. This is the last location. Here the data part is D, but address part is null. What is the meaning of this? There is no the next element. It is the last element. If the address part is null, what it indicates? It is the last element in the list. Okay. So head means what it indicates? It is the first element in the list. Okay. So this is the list representation of the data. Okay. And here suppose ఇక్కడ వస్తే బాగుంటుంది. So instead of horizontal, I am drawing the list vertically. So arrow marks, where it is arrow marks. Okay, shapes. Okay. Suppose here the element is 5, here it is 10, here it is 20, and here it is 30. Okay. And suppose the address of this location is 100 and address of this location is 102, 102, and this is 104 and this is 106. Sorry, here these are not the contiguous memory locations, non-contiguous memory locations. So it is those are not side by side. Okay, at random locations. Okay, suppose the first one is at 1000, second one is at uh, first one is at 100, second one is suppose it may be at 200, 150. 355 or 356, like this. Okay, so like this, maybe the addresses of these elements. Okay, so now the addresses are not side by side. Okay, not side by side means non-contiguous memory locations. Okay, now the first location, so data part, what it holds, it holds the address of the element 10. What is the address of the element 10? It is 200. Second location, data part, it holds the address of element 20. It is 150. Now here it holds the address of the next element 30. It is 356. Here it holds the address of the next element. There is no next element. It is the last element. So it is indicated by null. Okay, null indicates it is the last element. Okay, and this is the head node. Head indicates it is the first element. Okay, so this is the representation of the linked list. Okay, so here now look at the operations, how we can do the operations on this insertion, deletion and display operations mainly. Suppose I want to insert the element 15. I want to insert the element 15. Okay. Uh, in case of array, how you can insert the element 15 here? So 15 ఎక్కడ ఇన్సర్ట్ చేయాలి? 10కి 40కి మధ్యలో 15 మనం ఇన్సర్ట్ చేయాలి. 10కి 40కి మధ్యలో ఇన్సర్ట్ చేయాలి 15. సో అప్పుడు మనం మధ్యలో ఇన్సర్ట్ చేయాలంటే ఏం చేయాలి? ఒక లొకేషన్ క్రియేట్ చేయాలి. ఒక లొకేషన్ క్రియేట్ చేసి, ఓకే, ఇప్పుడు ఇవన్నీ కూడా కాపీ, ఇప్పుడు ఏం చేయాలి? ఈ పక్కకు మూవ్ చేయాలి. ఓకే, ఇప్పుడు అన్ని పక్కకు వచ్చేసాయి. ఇప్పుడు ఇది ఎంటీ అయిపోయింది. Now it is a of 4. Now it is a of 5. Now it is a of 6. Now it is a of 7. Okay. Now here in place of 40 you can write 50. Okay. So this is the way of inserting the element 15 in the array data structure. Okay. So what we are doing here? We are increasing the size of array. Okay. Why? Because I want to insert one element, so I need to increase the size of the array by 1. Okay, and then to insert the element 15, where I have to insert the element 15? Between 10 and 40. Okay, so to create the space for the element 15, I am shifting all the elements from 40 to 500 to the left by 1 position. Okay, so that here ఒక ప్లేస్ ఎంటీ ప్లేస్ అనేది వస్తుంది. ఓకే, సో ఇక్కడ ఇప్పుడు ఈ ప్లేస్లో మనం 15 రాసాం. ఓకే, ఆర్ యూ గెటింగ్ మై పాయింట్? వాట్ వీఆర్ డూయింగ్ హియర్, టు ఇన్సర్ట్ an element in the array, what is the first one you have to do? You need to increase the size of the array by 1. If you want to insert 2 elements, you need to increase the size of the array by 2 positions. సో ఎన్ని ఎలిమెంట్స్ అయితే మనం ఇన్సర్ట్ చేయాలనుకుంటున్నామో అన్ని పొజిషన్స్ మనం ఇంక్రీజ్ చేయాలి. దట్ ఈస్ ద ఫస్ట్ వన్. ద నెక్స్ట్, ఫైండ్ అవుట్ ద ప్లేస్ టు ఇన్సర్ట్ ద ఎలిమెంట్. ఓకే, హియర్ ద ఎలిమెంట్ 15, what is the correct place for the element 15? So that the data may be in the sorted order. So it is the 15. So it should be between 10 and 40. ఓకే, 10కి 40కి మధ్యలోనే 15 ఉండాలి. ఓకే, సో మనం ఏం చేస్తున్నాము, 10కి 40కి మధ్యలో స్పేస్ రావాలంటే ఏం చేయాలి? ఇక్కడ మనం స్పేస్ మధ్యలో మనం క్రియేట్ చేయలేం కదా. స్పేస్ మధ్యలో క్రియేట్ చేయలేం కదా. సో ఇనిషియల్లీ ద సైజ్ ఆఫ్ ది array is a of 7. Now the size of the array is a of 8. Size of the array is a of 8. Okay. So we can't create the space at the middle. ఖచ్చితంగా మనం స్పేస్ అనేది ఎంటీ స్పేస్ అనేది ఎండ్ ఆఫ్ ద లిస్ట్ లోనే క్రియేట్ అవుతుంది. సో ఆఫ్టర్ క్రియేటింగ్ ద స్పేస్ వీ నీడ్ టు షిఫ్ట్ ద ఎలిమెంట్స్ బై 1 పొజిషన్ టు ద లెఫ్ట్. అప్పుడు ఇక్కడ స్పేస్ వస్తుంది, 10 పక్కన స్పేస్ వస్తుంది. ఓకే. సో ఆ స్పేస్ లో మనం 15ని ఇన్సర్ట్ చేస్తాం. ఓకే. అగైన్ ఐఎమ్ రిపీటింగ్ ద ప్రాసెస్. So this is the initial array. Okay. Now to insert the element 15, what I have to do first, increase the size by 1. Increase the size by 1 like this. Okay. Now shift all the elements by 1 position left, 1 position right, sorry not left, 1 position right, from the element 40 to the element 500. Okay. So place of third location. Now here it is 500. Here it is 100. Here it is 30. Next 40. Now this is vacant. Okay. Now here write 50. Okay. Like that I am inserting the element. Okay. So what are the operations we are doing to insert the element 15 in the array? Okay. All these operations we are doing. You remember these operations. Okay. Now do the same operation for the list. Okay. Here how can you insert the element 15 in the list representation? Okay. To insert the element 15, so create here okay element 15. Here it is 15. Okay. it is 15. Now 15, a location is created. So in this location, the data part is 15. What is the address part of this location? Address part is, suppose the address of this location is, how much difficulties I am facing. Suppose address is 400. Address is 400. This location address is 400. Okay. So 15, where I have to insert between 10 and 20. Okay. So after the 10, the next element should be the 15, not 20. Okay. So in this location, okay. So data part should be data part. Sorry, not data part, address part. Okay. In this location, data part is 10 and address part, here it is 150. Here it is 150. What is 150? It is the address of this location. 150 is the address of this location. 356 is the address of this location. 200 is the address of this location. 100 is the address of this location. Okay. So here ఇక్కడ 150 ప్లేస్ లో మనం ఏం రాయాలి ఇప్పుడు 400 రాయాలి. 400 రాయాలి. ఓకే. వై బికాస్ 10 తర్వాత నెక్స్ట్ ఎలిమెంట్ ఏమి ఉండాలి ఇప్పుడు 15 ఉండాలి. 15 అనే ఎలిమెంట్ ఏ అడ్రస్ లో ఉంది 400 అనే అడ్రస్ లో ఉంది. సో 400 రాయాలి. అండ్ ఆల్సో దిస్ లింక్ this లింక్ ఎలా ఉండాలి? లింక్ ఇప్పుడు ఎక్కడి నుంచి ఉండాలి? Okay, 10. Here it should be points to the 15. Okay, and what is the address part here? What address you have to write here? 15. After 15, what is the next element? ఏం ఉండాలి 15 తర్వాత నెక్స్ట్ ఎలిమెంట్ 20 ఉండాలి. ఓకే, సో హియర్ యూ హ్యావ్ టు రైట్ ది అడ్రస్ ఆఫ్ ద ఎలిమెంట్ 20. ఇట్ ఈస్ 150. Address of the element 20 is 150. So this shapes రావట్లేదు. యారో మార్క్ కరెక్ట్గా పెట్టాలి. That is the arrow mark. Okay. Now look at 5. Data part is 5. Address part is 200. So it holds the address of the element stored at address of the next element 200. So 5 tarvata you can access the element 10. So here the address part is 400. So what is 400 location? Here it is. So after 10 we can access the element 15. So here what is the address part? 150. So where is the 150? So here it is 150 location. Okay. Here the what is the data? So after 15 you can access element 20. And here what is the address? 356. What is 356 address? Here it is. Okay. So after 20 you can access 30. That is the last element. Okay. Data part is, address part is null. Okay. So this is the way of data representation in the list. Okay. So here what are the operations we are doing to insert the element 50? First operation is just a location is created. A location is created. So location ఎప్పుడైతే క్రియేట్ అయిందో ఆటోమేటిక్గా దాని అడ్రస్ కూడా క్రియేట్ అయిపోతుంది. The location is created. So in that location I am storing the element 15. Now we are changing the address part of this location and the address part of the element 10. Okay, address part of the 200 location. Okay, so ఇక్కడ ఒక చేంజింగ్, ఇక్కడ ఒక చేంజ్, ఈ రెండు చేంజెస్ మనం చేస్తున్నాం. ఓకే, హియర్ దెర్ ఆర్ నో షిఫ్టింగ్ ఆపరేషన్స్. సో ఇన్ కేస్ ఆఫ్ అరేస్ what we are doing, a location is created and then we are shifting the elements by one position from the element 40 to the element 500. Shifting operations. Okay, here there are no shifting operations. We are linking the pointers. What we are linking? We are linking the element 10 to the 15 and element 15 to the 20. Okay, 10 ఇక్కడ మనం 400 రాసేస్తాము. ఓకే, దట్ ఈస్ 400 అడ్రస్ రాసామంటే మీనింగ్ ఏంటిది? సో దిస్ ఈజ్ లింక్డ్ విత్ దిస్. Okay, 400. Okay, so link here, first link. So 5. So this points to this. This points to this. So look at the arrow marks. Points to this. And this points to this. And this to this. Okay. So that is, this node is linked to this node. Again, this node, the newly created node, this is linked to the this. Okay. So like that, we are linking the nodes here. This is the first node, second node, third node, fourth node. Initially 4 nodes, 4 elements. Okay. Now to insert the element 15, we are creating one more node. Address of that node is 400. Okay. And in this node, element 15 is stored. After that, after storing the element 15, what we are doing? We are linking this node to the node 200 and also to the node 150. Okay. 200 is the previous node to this. 150 is the next node to this. Okay, అలా ఉండే విధంగా మనం దీన్ని లింక్ చేస్తున్నాం. 400 నోడ్ 400కి ముందు నోడ్ 200 ఉండాలి, నోడ్ 400కి తర్వాత నోడ్ 150 ఉండాలి. అలా మనం లింక్ చేస్తాం. లింకింగ్ ఆపరేషన్స్ ఆర్ డన్ హియర్, నో షిఫ్టింగ్ ఆపరేషన్స్. ఓకే, సో కంపేర్డ్ టు ద షిఫ్టింగ్ ఆపరేషన్స్, linking operations takes less time. Okay, so computing time of insertion operation is low compared to the arrays in the list. Okay, like that deletion operation is also computing time of deletion operation is also low in the linked list compared to the arrays. Okay, that means we can do the insertion and deletion operations in very less period of time using the linked list than in the arrays. Okay, So those are that is the advantage of list over the arrays. In arrays, insertion and deletion operations are not easy. Shifting operations we have to do in arrays. But in linked list, no shifting operations. What we are doing, only the linking operation. So linking operations are easy compared to the shifting operations. Okay. సో మనకి ఈ లింకింగ్ ఆపరేషన్ కష్టంగా ఉండొచ్చు కానీ కంప్యూటర్కి లింకింగ్ ఆపరేషన్ ఈజీగా ఉంటుంది. ఓకే. సో తక్కువ టైంలో ఈ లింకింగ్ ఆపరేషన్స్ పర్ఫామ్ చేస్తుంది. అదే షిఫ్టింగ్ ఆపరేషన్స్ పర్ఫామ్ చేయడానికి ఇట్ టేక్స్ సమ్ టైమ్ టు ది కంప్యూటర్. ఓకే. So this is the array representation and list representation. So what you understood about the list is also the collection of elements. So we can define the list like this. Here the each location is called as the node. So list is the collection of nodes, and each node contains the two parts. One is the data part and another one is the address part. Okay. Each node means location. Each location contains the two parts, data part and address part. List is the collection of nodes. Each node contains the two parts, data part and address part. First node is called as the head node, and the last node, address part of the last node is null. That indicates it is the last element in the list. Okay. So this is about the list data structure. I hope you understood about the list. What is list and what is the data representation of the list? How to insert the element in the list data structure? How to insert the element in the array data structure? Okay. So in the array data structure, here also you can insert the element at the beginning of the array, at the end of the array, at the middle of the array. In the list also you can insert the element at the beginning, at the end, at the middle of the array, or at any required position of the array. So those operations I will explain in the next video. Thank you.